Alright, day 10. Now, I realized, in the meantime, that disable preview, that the texture atlas is, it's fairly easy to make the gaps 1 pixel in size rather than 2 pixels. Inputs, the raw, yeah, that. So this gap is 2 pixels, and it's fairly easy to make it 1 pixel. So I'll just do that. So then, when we pack the rects, okay, so we pad out each rect by 1, as opposed to 2. We pack that, then we pad out the atlas. Okay, so there is the atlas. Okay, so right here we pad out the atlas itself, width plus equals 1, atlas height plus equals 1. Okay, so each rect that's being packed is padded by 1. The atlas itself is padded by 1. And then when we copy stuff over, we do need to shift rect x and rect y by 1. So if we sort of conceptualize it as each rect is padded on the left and at the top, that means we need to shift by 1 to copy the actual pixels over. And then the atlas location, so we do need to shift this by 1, but we only need to subtract 1 from the dimensions. Left top, and this padding is just on the right of the atlas and at the bottom of the atlas. So that, I believe, is correct. Let's go to, let's verify. Well, at least it works, so that's something. Alright, well, this gap is correct. This gap is 1 pixel, so that's good. The gap on the right seems to be 1 pixel as well. On the bottom is 1 pixel. In between it's 1 pixel. And if we look at the output, yeah, the output seems to be outputting correctly. Alright. Well, that's all we needed here. Alright, we don't need anything else. Reduce gap between textures in atlas. Okay, so that's that done. We have some to-dos. Oh yeah. So can we just add some stuff to the structs to like make it so we don't need to do so much like this finicky stuff? Maybe, actually. I mean, we have these arrays. So like right here, we could just add like, well, can we actually? I mean, well, what do we have? We have frames. Frame data is on oh my god. Yeah. So that's the frame. I mean, Maybe not. Well, let's see. What can we do anything with the frame? What's in the frame? Chunks. Chunks are in the frame. And it's essentially just, yeah. There's just a count of chunks. And the chunk is one of those. Well, what if we just say that a frame just has a bunch of chunks here. Oh, well, we kinda need to define what the chunk is. And then it's not really a header anymore, it's just a frame. So we cast frame data as a frame. Then assert that frame magic is that. Then chunk data would just be frame chunks. Does that work? That does work. Okay. Well, that is simpler than what we had before. Now, if this is a frame, can't we just do the same thing with, like, the whole file? Doesn't it just have an array of frames? Ace frames. Just that. I suppose it's not really a header anymore, it's just an ace file. Yeah, this is just the whole ace file. That's what it is. So cast it, assert the magic is correct, then frame data, I mean this is just ace frame, right? Frame is ace frames, and we don't even need this anymore. Ace frame count. Yeah, so there's the frame pointer. So we go in, and then we need to advance the pointer. Like this. Okay, so chunk data. Now chunk data could just be chunk, can't it? Like we can just do this. And then we don't need to do that. So just initialize it to frame chunks. And then each time through advance it. Except that yeah, so when you advance it, we kind of want to advance just by bytes, not by... not by size. Okay, so what's this? Okay, Okay, we're not allowed to do this. Yeah, well, I mean, I can't just add the size, because then it will... Actually, what is it even gonna do? There's a variable sized field in there. Ace frame. Well, let's find out what it does. I mean, that compiles somehow. Okay. So we go up to here. Chunk is that number. Chunk size is 22. So we're gonna advance that by 22. Can we cast to U64? Yes. Okay, so copy value. Can we have an expression here? Yes, so that's the number that we expect to see. That we want to see, ideally. Where's the F10 button here? That's the number that we actually saw, which is different. Okay, so we can't just do that. It advanced by a lot. Yeah, so we can't just do that. So I guess we're gonna have to do some pointer manipulation, like what, like U8 star temp is like, well, even void star will work. Void star temp is chunk, and then temp plus equals chunk size, and then chunk equals temp. Like that's what it wants me to do. And that is just, I mean, that does work. We are parsing the file correctly. Of course, this is really weird. Like, why would you need to do it this way? Like, what? How does a variable size struct even have a size? Like, well, let's see. Struct temp int, I guess I32 vals int x is size of temp. Like, what's this? Size of struct temp. Oh my god, what? No. Okay, what's x? 4. Oh. Oh, so it's just one of those. Okay, well... You'd think this would be some kind of warning. Why would this be allowed? Like, clearly if you have a variable sized field, you're not really gonna have one of those on the stack. Although maybe, I mean, I don't know, what's the use case for that though? It's probably just gonna have a pointer. But anyway, that's the simplified pointer arithmetic that I thought about. So do we really need this extra scope? Do we really need any of these extra scopes? Probably not. Probably not. We can just we can just remove both of these. Now. Name, path, content. And that is the ace, that is the magic, that is the frame. And there is, okay, does this work? It does. Okay, but hopefully we don't get any warnings. I think, yeah, it doesn't seem to. Okay, well that's the other to do. Now, better way to move by pixels. I don't really know how to, like, how that's gonna go. That's for later. Okay. Simplify pointer. That is. Simplify ace parsing. Let's just say that. Alright, actually, another thing I wanted to check, does this work? Like, invalid preprocessing directive. Okay, so nobody implemented this, apparently. Nobody implemented this, even though it's in the specification. Now, another thing is CCPP. Like, do we have the... No, we don't, actually. Alright, C++, well, okay. C language standard. C standard. Default C standard. Okay, can we do C23? And just do the latest, like whatever. Just do the latest standard. Okay, apparently there is an error somewhere. Type def is not allowed. Invalid preprocessing there. Oh yeah, that's not an error. It's not real. Yeah. Wait, does when we compile, right? Can we just tell Clang to use the latest C standard? Clang help temp txt temp. Alright, standard dash cl dash std OpenCL. Oh, okay. No. Oh, God, I think that was it. No. What? GNU keywords. Okay, language standard. Maybe language standard is what I need to. Dash std. There we go. We don't get a list of what it allows there, but you know, guess we'll just have to guess. Dash std equals, well, what if I just do that? Does it compile? Ah, there we go. Alright, so C2X. Okay. Does this mean we don't have to include std bool anymore? Yes. Well, that's something. Build. Yep. Remove std bool. Alright. Okay, so what's next for the actual program though? Well, oh my god. Okay, well the movement is smooth. So that's something. Presumably we want... Okay, well, we want to sort this out. Certainly. Because right now, what's happening here? We're just pushing a rectangle. We're just saying where it is and where the textures are. We have no way to identify the textures. We're just saying, well, this is the first one, this is the second one. So if we swap these around, it's gonna be, we're gonna be controlling Bloomrian. Yeah. Yeah, so I guess this is next. We do have a coordinate system. Do we, actually? Well, yeah, kind of. So this is world units. I mean, that's essentially defined by the camera. We're moving these rectangles in, just saying where they are. Oh yeah, texture IDs. I'll just put it to do here for later. Texture IDs. Okay, to remind myself what it is that I'm supposed to be doing. Add a to-do. Alright. Okay, what time is it? Yeah, time for me to go. That's all I have time for today. Thanks everyone.